Hello everybody and welcome back. In this tutorial, we're going to be creating our very first metal material, and we're going to be creating it from complete scratch, explaining the workflow from start to finish. Now the metal material we'll be creating is going to get applied to our sofa's railing here. And so that's going to be the end result of this tutorial. We're hoping it's going to be a fun one. We're hoping you're going to learn a lot. And so let's just jump right into it. So the first thing that we'll want to do here is we're going to want to create a new V-Ray node material. We're going to be working with the V-Ray node material. You can use the standard material if you prefer it, but we really like nodes here, so we're going to go with nodes. All right, let's give this material a proper name. Let's call it a metal material. And now let's take a little pause to discuss a couple of basic things. So when it comes to creating metal materials, you, generally speaking, have two different workflows you can adhere to. One of the workflows is centered around the IOR parameter. It is a very common workflow, and like we said, it revolves mostly around the IOR value. The other workflow is centered around the metalness parameter, and that is the so-called PBR workflow. This one is sort of a newer workflow, and it's important to note that both of these workflows are physically based. They are physically realistic. It's just that by and large, one is newer and it might also require tweaking less variables, and it is seemingly becoming the new standard. But that said, both are physically based, so whichever one you go with is up to you. We're going to showcase both of them in this tutorial, and we're going to start by showcasing the IOR-centric workflow first. So what we'll do here is we're going to open up the node editor, and then we're going to start prepping our material here. Actually, before we do that, let's just apply our material here to our sofa's rails. So we're going to expand the sofa null here, and by the way, the sofa is a Cosmos asset, so you have access to it yourself as well. The only thing we changed here is we made the Cosmos asset editable. Okay, so now let's just go through these selection tags here. And to do that, we're just going to get a little bit closer to the sofa with our camera here. So kind of like this, right? And now let's just go through these material selection tags here just so that we can see which one selects that metal rail part. And it's this one. So the next thing that we're going to want to do here is we're just going to take our material, apply to this object, and then we're just going to want to make sure that the material that we've applied here is limited by the selection tag we have here. Okay, so with that done, let's get back to our material here. The first thing that you'll want to tweak is the diffuse color value. Since we're creating a metal material, and this metal material is going to be very chrome-like, well, we don't want our material to have any sort of a diffuse component to it. The diffuse component you can think of as that really rough base layer that gives non-metal objects its color. And since we're creating a metal material, we're going to be turning this component off by tweaking its color, setting it to pitch black. All right, so with that done, we can focus our attention on the reflection channel. So metal materials are typically, well, reflective. So let's up the reflection color here to its full strength. And now, if you take a look at our material preview here, you're going to notice that this material ain't looking metal at all. It's more like a pop rock material. That's a joke. Point is, it's not looking very metal yet. What we need to do next is we need to play around with the IOR parameter. So right now, as you can see, our Fresnel IOR parameter is locked out. That's because in the real world, the index of refraction, so that's IOR in short, for any given material is the same for both the reflections and refractions. So that means that if we go under the refraction menu here, you'll see that we can tweak the IOR value from in here. But since metal materials aren't refractive, meaning we won't be using refractions at all, we can just artificially split the IOR control for the reflections and refractions by unchecking the lock Fresnel IOR parameter. And now we can tweak the IOR just for the reflections here. So with metal materials that are not damaged, not painted, not too oxidized, you want to go with a relatively high IOR value. The metal material that we're going to be creating here is going to be a chrome material. So let's set our Fresnel IOR value to 6 or so. And as soon as we do that, you can see that the material preview here now gives a much more desired look, because our material is actually looking a lot more like a metal material right now. And you can see that the same holds true when we look at the interactive render here. And by and large, that is pretty much all you need to do to create a basic metal material using the IOR workflow. Now, we're not just going to leave it at that though. We're going to add some details to it, some imperfections that are going to make this metal material a lot more realistic. Now, before we actually start adding details to our metal material here, let's just get a better vantage point on our rail there on our sofa. So we're just going to go into our main camera and we're going to get a lot closer to our rail here. Okay, so maybe getting in as close as this might work. I think it will. Let's just set up a nice little render region and we're good to go here. So let's bring up the node material editor again and let's focus on the glossiness parameter first here. So the glossiness parameter, what it does is it controls how sharp or mirror-like or glossy your reflections are going to be. So right now we have our glossiness set to 1, and if you take a look at our interactive render, you're going to see that our reflections are indeed very glossy, very mirror-like. Now, if we start lowering the glossiness parameter, if we lower it down to 0.7 or so, you're going to see that now our reflections got a lot blurrier, a lot more rougher, a lot more diffuse looking, if you will. And so that's what the glossiness parameter does here. Why is the glossiness parameter super important? Well, if you take a look at the materials that are all around you in the real world, you're going to see that, you know, they have imperfections to the reflections. Okay, so certain parts of your materials are going to be more glossier than other parts. And so, you know, tweaking this parameter here is very important for whenever you're trying to achieve that realistic look. But now, as you've probably noticed, if we just tweak the glossiness parameter, we're adjusting the glossiness on our material as a whole, right? So we have this value here that's controlling the glossiness across the entire material with no exceptions. What would happen in reality, however, is that there will be certain small parts, you know, maybe some fingerprints that would be less glossy, then other parts would be super glossy, and so on and so forth. So how do we get that look going? Well, we are going to have to bring in a imperfection texture map. Okay, so to do that, well, we have a map already prepared here. It's this map right here. And if you take a look at it, it's just this black and white map. That's basically just one big, well, imperfection map, if you will. The darker parts in this map are going to tell our material that these parts are going to be less glossy, and the lighter, the whiter parts are going to be glossier. Okay, so let's just take this map here and let's just plug it into our node material editor. Let's just bring it in there. And now what we want to do is we just want to take this bitmap and we want to plug it into the glossiness slot in our material here. Now, immediately you're going to see that the mapping is wrong because everything just became super, super rough. All the reflections are super diffuse right now. So what we're going to do real quickly here is we're just going to select our material tag here, and we're just going to set the projection to be cubic, and we're going to lower the length U and V values a little bit here. And we're going to lower them down to 50%. And now you can see that, well, exactly what we just talked about is happening. So the lighter parts in our texture are glossier, okay? And the darker parts of our texture are saying that those are the areas where we want the reflections to be super diffuse or super rough, if you will, or not glossy. Okay, Now, if we take a closer look at this rail, you're going to see that we have some seams happening, but we won't worry about them just yet because we're going to solve that real neatly a bit later on before we start concluding this video. So now the reflections, as you can see, they're not really looking the way we want them to be. This effect is just too intense. So what we're going to have to do is we're going to have to tweak our glossiness map here, okay, or our imperfection map. Now we could do this in our post-production tools. We could lighten up those darker parts in there, because as you can see, those darker parts are really making our material super non-glossy, super rough. Or you could do that from right inside Cinema 4D here. So to do that, we're just going to click on this plus button here. We're going to go under the color sort of folder here. Then we're going to bring in a remap shader. Okay. Now we're going to plug this bitmap into the remap shader's input field or slot or however you want to call it. And then we're going to plug this remap shader into the glossiness slot of our material. Now, by itself, that didn't solve anything for us. But with the remap shader, we now have access to, remapping the values of whatever's inputted into the remap shader, which in our case is this black and white imperfection texture. So what we want to do here is, or what we will do here is, we're just going to take this handle down here and we're going to move it up to around 0.8 here. Okay, and if you take a look at our little preview here, what you've noticed happening is we've remapped those darker values to be a lot lighter. Okay, because that's exactly what we wanted to do, because the effect was too strong otherwise, right? And if we take a look at our interactive renderer right now, you're going to see that our material looks a lot more realistic than it did before. If we zoom in closer, you're going to see that there's some areas here that are just a little bit rougher than all of these other parts, right? You can kind of see it real nicely here where the highlight is at, and you can see some of that effect happening here as well, right? And so that's how you typically tweak and work with imperfection maps that you plug into the glossiness slot. Now, if you have glossiness maps, a lot of assets come with specific glossiness maps. You can plug those into the glossiness slot. That's what they're there for. But you can always use the remap shader to remap them as well if you're not happy with the result that you're getting. Okay, and just look at that effect. Now our metal material looks a lot more realistic. Okay, but that's not all that we want to do here. We want to introduce some bumps and bruises to our metal material, you know. So what we're going to do next here is we're going to bring in another texture, another bitmap, and it's going to be this bitmap right here. Okay, as you can see, this is a bit of a scratch imperfection map, scratches imperfection map, however you want to call it. And we're just going to use this one to introduce some bumps and bruises to our metal material. So let's take this map, let's plug it into our node material editor, or let's bring it in, right? And then we're just going to take this bitmap and we're going to plug it into the bump map slot in our metal material. And just like that, you're going to see that, well, the effect is looking kind of cool, but it's obviously way too strong. So we're going to lower the bump amount down to 0.1, and let's see how that's looking. Of course, we got to give it a second to refresh. Maybe we could make this render region a bit smaller. And as you can see, this is still way too strong. So let's maybe lower it down to 0.06 centimeters. And so we're just decreasing the strength of this bump effect. That's still a little too strong. Let's lower it down to maybe 0.03 centimeters. And so this is, you know, how you typically tweak the bump map values or any other values in your materials. You know, you get up close to your material and then you just tweak things left and right. So I think this is kind of looking pretty cool. It might be just a little bit too strong still. So let's go down to 0.06 centimeters or 0.006 centimeters. And let's see how that's looking. And we're just trying to add some small bumps and bruises to our material. And as you can see, we're definitely doing that. It's barely visible, but it adds, you know, some extra details to our material here. So just like that, we've created a pretty realistic not that too sophisticated material, as you can see, and the end result is looking pretty great, pretty realistic, and it was that easy to set up. All right, so what we demoed so far was how you can create a metal material using the IOR-centric workflow. Now, what we're going to showcase next is how you can create a metal material using the PBR workflow. So before we embark on that journey, let's just select our current metal material and let's rename it to be called Metal IOR material. And then what we're going to do is we're just going to create a new V-Ray node material, and we're going to call this material Metal PBR material. Okay, then we can apply this Metal PBR material onto our rails. Okay, onto our rail, and then we're good to go here. So let's bring up the node material editor, and let's bring up the materials properties here. So we're going to focus on the reflection menu first here. And when you're adhering to the PBR workflow, the first parameter that you're going to want to tweak is the metalness parameter. So right now, the metalness is set to 0, which means we're creating a dielectric, or in layman terms, we're creating a non-metal material. If we change our metalness parameter here, if we push it all the way up to 1, well, now we're creating a metal material. You can use in between values here if you so want to, but that will result in a blended material that is not physically accurate. Okay, so that's important to note. With metalness, if you want to be physically accurate, you want to use values that are either 0 or 1. Okay, so next up, what we want to set up is the reflection color as well. So we're going to set this one to be fully white, and this way, we're just going to get that proper reflectivity and preservation of energy happening. Without the reflection color being set to fully white, the glancing angles on our materials will never be 100% reflective, which they typically are, but it does depend on the type of metal material that you are trying to recreate. So, broadly speaking, having your reflection color set to fully white is the proper way to start building up your metal materials using the PBR workflow. Now, as for the diffuse component of our material, since there is no diffuse color in metal materials, the diffuse color itself here becomes what is known as the base color, or the albedo color. So what that means is that with this parameter here, we control the reflection strength and the reflection color of our metal material. So we're going to make the base color here red, and as you can see now, our material is, well, red. If we lower the value here, if we make this a dark gray material, you're going to see that now our metal material here is going to be a lot less reflective. Okay. Now, typically for albedo values for most metal materials, you do want them to be a little bit below 100%, so maybe around 90% or so. But if you want to have some good starting points, you're suggested to check out our blog post that you can access on our blog section. It's called Understanding Metalness. And in here, you're going to see that you have a couple of, well, preset metal values that you can use. So if you want to create a chromium material, then for the base diffuse color, you would use these values. For the reflection color, you would use, well, fully white values. And for the metalness, you would use a value of 1, because obviously chromium is a metal material, right? Now you're going to see that you have the IOR parameter available to you as well. But in the context of the PBR workflow, the IOR parameter controls how much of those grazing angles that you define with the reflection parameter. It controls how those grazing angle reflections blend in with the overall reflectivity that you've defined in the base color slot in the diffuse menu. It's a functionality that can be useful, but typically doesn't have a profound effect on your material. It's more of that nitpicking advanced functionality, if you will. Right, so with all that explained, what we can now do is we can create all of the same effects, or we can add all of the same details that we did for our IOR metal material. So we're going to bring in those same textures we did before. So we're going to bring in this imperfection texture and then this bump texture or bump imperfection texture. We're going to plug the bump imperfection texture into the bump map slot here. We're just going to make sure that the strength here is set really low. I think we've used a value of 0.006 or so, right? And we're just basically we're just going through the exact same steps as we did with the IOR metal. So we're going to take our glossiness imperfection map here, if you will. We're going to bring in a remap shader because we want to remap it, right? We're just going to plug the bitmap, the glossiness bitmap into the input of the remap shader, and we're going to plug the remap shader into the glossiness slot of our material here. And then we're just going to go into the remap shader itself, and we're going to up those darker parts in our textures to be a little bit lighter so that the effect is a bit more realistic. Now looking at this metal material, because we're not adhering to some preset values, we can experiment here a little bit. I think the metal material is looking just a little too reflective, so I'm going to go under the base color here. I'm just going to lower the value here a little bit, make it just a little bit darker, so kind of like this. Okay, and there we go. We've created a metal material using the PBR workflow. Again, if you want to learn more about the PBR workflow, make sure to check out our blog post because it can be really useful. All right, now before we start concluding this tutorial, there's still one more topic we'd like to talk about, and that is how do you get rid of those seams on the rail from happening. You can't see them right now because the maps we're using to drive our glossiness and bump imperfections are really subtly affecting our material right now. So for our specific material here, we probably wouldn't have to bother with resolving those seams, but still, you know, this is a tutorial, and while we won't go too much into the details, we'd still like to show you how you can quickly get rid of those seams without having to UVW unwrap the rail mesh itself. So just to make the seams more visible, what we'll do here is we'll go into the remap shader and we'll reset its spline so that the remap shader is basically not doing anything anymore. And with the material set up like that, if you'll remember, we'll get that strong glossiness map doing its thing, meaning some areas of our rail here will be super glossy and others will be super rough. So now you can clearly see the seam happening. You can see it going across the entire rail here, right? So what's the easiest remedy here? Well, all you need to do is you need to bring in a new shader. So just go in under the color layer here and you bring in a triplanar shader. Well, not color layer, but color folder. And all you have to do is you need to bring in the triplanar shader in here, and then what you want to do is you just want to plug the remap shader into the triplanar shader's texture slot. Then you plug the triplanar shader into the glossiness slot, and you're going to see that not much is happening. Everything's pretty much exactly the same as it was. Well, that is because the triplanar shader needs the material projection to be set to UVW mapping. So we currently have it set to cubic. That's not going to work. We need to set it to UVW mapping. And as soon as we do that, you're going to notice that those seams are virtually gone. Now you can still kind of get a sense that a seam is happening here, right? But what you could do in this case is just simply go in the triplanar shader's properties right here and just play with the blend parameter. So just up it to say 0.7 or so, okay? And now you're going to notice that that seam is even more blended out of there, okay? And so that's how you can use a triplanar shader to quickly get rid of those seams. Now, because the triplanar shader works on a per map per shader basis here, essentially, what you want to do is you want to copy it and have it apply to the bump map as well, because this is the other map that we're using in our material here. So we're just going to take the bump bitmap here, bump imperfection bitmap, and then we're just going to plug that triplanar shader into the bump map slot right there. Okay. All right, so now we're doing that triplanar magic for this bitmap here as well. And so now all we want to probably do here is just up the remap shader to a value that we had going before, right? Give the thing a second to refresh, and just like that, no more seams anywhere. And we've ended up with this realistic, great looking material without fussing too much around with its setup. And with that, we're concluding this tutorial. We'd like to thank you for tuning in. We hope you've learned something new. And if you have any constructive criticism, any praise for us, or maybe even a wish list that you'd like to share with us in terms of what you'd like to see from future tutorials, well, please do let us know in the comments. Thank you for tuning in, and we'll see you in the next one. Take care, everybody.